let's discuss sine law. So what does sine law say? Well, according to sine law, if you have sine of A, that's angle A, over side A, that's equal to the ratio sine B over B, and that's equal to the ratio sine C over C, where if you need a reminder, A, B, and C, uppercase, represent your angles, A, B, and C, these angles here. And the lowercase letters represent the sides opposite of those angles, so A, B, and C, just like that. So if you took sine of this angle and divided it by this side, you would get the same number that you would get by dividing sine of B by B, or sine of C by C. And what's cool about this relationship is that it's reversible in a sense. What I mean by that is you can turn all these fractions upside down and the ratio holds true. You could say A over sine A is equal to B over sine B, which is equal to C over sine C. And when you think about it for a minute, it kind of makes sense that this is true, right? Like if you have one fraction equals a fraction and you flip them both, of course they're still going to equal each other, right? Like 1 over 4, if you say that equals 2 over 8, well, you could also say that 4 over 1 is equal to 8 over 2, right? Like both of these statements are true, right? As long as you flip them both, it's still true. So of course this is true. Now, with that in mind, we can solve some questions, right? For example, if they gave you a triangle, big triangle like this, and they gave you some information, they said that this angle here is 60 degrees, and this angle over here we'll call 40 degrees, and we'll call this side Y, and this side X, and here this can be angle theta, and this length over here we can say is 10 feet. And let's say the question here is solve for everything, right? Solve for all the sides, all the angles. In other words, solve the triangle, right? That's the question. Well, what could we do? Well, the first thing I would recommend doing is figuring out this theta. And the reason I say that is because if you have two angles in a triangle, you essentially have all three because they all add up to 180. So theta is very simple to find. You just do 180 minus 60 minus 40. That's going to equal your angle theta, right? Because theta plus 40 plus 60 equals 180. So 180 minus 60 is 120, minus 80 or minus 40 is 80 degrees. So 80 degrees is equal to theta. So he's put that 80 right there. Now, all the angles are done. Let's worry about the sides. How can I find y or x? Let's start with x, right? How could we find x? Well, we can use our sine law, right? We can't use SOHCAHTOA, we can't use the trig ratios because this is not a 90-degree triangle. That's why we have to use the sine law. So I'm going to write my first ratio, right? Sine A over A, that type of thing. Except instead of A, I'm going to use some real values here. So 10 is the only side length I really have. So I'm going to go 10 over sine 60 degrees because 60 degrees is the angle across from that. And see how I put the side on top and the sine on the bottom? The reason is because I'm going to equate this to the ratio that has x in it, and I want to put x on top just to make it easier to solve for. So x over sine 40 degrees because 40 is the angle across from the x. So you could have done this the other way. You could have said sine 60 over 10 equals sine 40 over x. It would just be a little harder to isolate x. This is nice and simple, right? You just multiply both sides by sine 40. So 10 sine 40 over sine 60 is equal to x. You can do that on your calculator. You'll get for x 7.42 feet approximately, right? It's a rounded answer. Okay, that's what you get. Now, we also have to solve for y. Now, I would say use the same ratio here to compare to our y. So 10 over sine 60 degrees is equal to y over sine 80 degrees, right? Because the 80 degrees is across from y. Multiply both sides by sine of 80 degrees. You get 10 sine 80 over sine 60 is equal to y. You compute that on your calculator, and you get y equals 11.37 feet, right? Again, approximately. And that's your final answer. Let's do another example. Let's say I have a triangle. This time looks something like this. And I have this angle here is theta. This angle over here is 30 degrees. This side length here is 20 meters. and this side length over here is 10 meters. And for this one, I just want to solve for theta. Okay, what is theta equal to? So you can do sine theta over 20. See, this time I'm putting the sine on top because I'm trying to solve for theta, so I want the theta on top of my fraction just to keep it easy, right? You don't have to, but keep it simple. And that's going to equal, well, I'll use the other pair of information I have here, sine of 30 degrees divided by 10 meters, right? And then you solve for theta. So I multiply 20 to the other side, so sine of theta equals 20 sine 30 degrees over 10. I have to get rid of the sine, so I'm going to sine inverse both sides. Those cancel, and you're left with theta is equal to that big mess. I'm going to calculate that real quick, and for theta, my answer is 90 degrees. So it just so happens that this is a 90-degree triangle, and that this drawing is obviously not to scale because this doesn't look 90 degrees, right? It's a little bit smaller. So if you wanted to draw this to scale, it would probably be more like this, where this is your theta, this is 10, this is 20, this is 30 degrees. That would be a more accurate drawing. However, that's pretty common for them to give you a triangle that's not drawn to scale, just so that you can't really guess what your answer should be, right? So 90 degrees is your final answer. Let's move on to another one. Let's say here's the ground. You have a tall building right here, and then a shorter building over here. And in the middle of the two buildings, you have a guy. We'll call him Mike. And Mike is standing 20 meters from the building on the right, and he's also standing 20 meters from the building on the left. Okay, now you have a guy up here. Call him Greg. Greg's just standing on the edge of this building, and then you got a guy over here. Name him Bob. Bob's just standing on the edge of this building. And Bob looks out towards Greg, and he sees that he can see Greg with an angle of depression of 20 degrees. Then he looks down even further, and he sees Mike. And he makes eye contact with Mike. And the angle of depression to get to Mike is 40 degrees. So this big angle here is the 40 degrees, just to be clear. Okay, now let's go over to Greg, see what Greg is seeing. Greg sees Bob, but then he also looks down, he sees Mike, right? He makes eye contact with Mike. And when he looks down at Mike, he notices the angle of depression here is 25 degrees. So from looking straight out to down at Mike, that's an angle of 25 degrees. Now, the question is, how far apart are Bob and Greg? Like if we were to imagine Bob and Greg holding a string in tension, holding it tight between the two of them, how long would that string have to be to go from Bob to Greg? What do we think? Well, there's some information here. I'm going to use a different color just because this is getting messy. But if you notice, this right here is a Z pattern if we make another horizontal. So this here is 25 degrees. And up here, we have another Z pattern. If I make a horizontal, this here is 40 degrees. Now this horizontal here, if you just went from there to there, would be 180. So therefore, we can figure out the angle in the middle, because these all have to add up to 180, right? So 180 minus 40 minus 25, that's going to give you 115 degrees. That's your angle on the inside here. What's also nice, and again, we're thinking about this triangle here, right? We're thinking about this big yellow triangle. We can figure out this angle here, because this big blue angle is 40. This part above it is 20. So this part in here must be the remainder, which is the other 20. So this must be 20 degrees, right? 20 and 20 make the 40. This whole thing is 40. This inside part is 20. Okay? Now with 115 and 20, I can figure out this angle here, because again, you knew the 25, but that's not the whole angle, right? But you can figure this out because 115 plus 20 plus whatever this is must add up to 180. So you could say 180 minus 115 minus 20 degrees, and that's going to give you 45 degrees. So this here is 45 degrees. What do we do now? Well, I have all my angles. Do I have any side lengths? Well, as a matter of fact, we do, right? Imagine now this triangle here. That triangle has a base of 20 because this length is 20. So we could figure out the hypotenuse of this right angle triangle, And that would give us a length in the yellow triangle, right? It would give us that length because they share that length. So how would I find that side? Well, I have a right angle triangle. I know the angle is 25 degrees. I know this length is 20. So to find the hypotenuse, I have the adjacent. I want to find the hypotenuse. Sounds like I should be using cos. So cos of 25 degrees is equal to the adjacent over the hypotenuse. Flip that around. Hypotenuse equals 20 divided by cos 25 degrees. Your hypotenuse will equal 22.07 meters. So that's this length here. Maybe I can put an arrow to that. 22.7 meters. Now what I would like to do is draw this from scratch, just our triangle, because it is getting messy. So come down here. We'll draw our triangle just like this. Again, we just found out this is 22.07 meters. That's this length. I know this is 115 degrees. I know this is 45 degrees. And I know this is 20 degrees. And I'm looking for x, right? I'm looking for this length here. I'll call that x. So the question is, how do I find that x now that I have all this information? Well, I have this side that I'm looking for and this angle across from it. I have this angle and this side across from it. I think I can do a sine law. So I'll do x over sine of 115 equals 22.07 over sine of 20, right? And I'm putting the x on top just to make it easier to solve for, right? So multiply both sides by sine of 115. So x is equal to 22.07 sine of 115 degrees divided by sine of 20 degrees. Calculate this and you're going to get 53.2 meters. So a straight line between Bob and Greg would be 53.2 meters. That's how long that length would be.